In this series of video, you will learn how to create a custom message and a service in ROS. As you may already know, ROS uses message type to communicate between nodes. As an example, ROS uses topic to communicate between nodes, and this topic has its own type that best represents the data that it has to transmit or receive. The structure of a topic is described by messages and services. So, as a recap, message and services are files where we put a specification about the type of data to be transmitted and the values of this data. ROS will use these files to create the necessary code for us to implement the message and service files to be used in our nodes. Let's start with the message file first. And what we're gonna do, we're gonna to create a new message that represents the battery status of our Roomba robots, for which we have drawn a pathway in the simulator environment of the TurtleSim node. Usually, it is a best practice to create a standalone package in our Catkin workspace environment that deals with message and service, in such a way that if we need to use that type of message, it will be very simple to include in other package. So we are going to create our Roomba message package with dependencies ROS CPP, ROS PI, and standard messages. And let's remove the include and src folder because we won't use them. The first thing that we need to do is to modify our package file and CMakeList file. And let's start with the package file one. So first open Visual Studio Code and open the package.xml file. We need to add a build depend tag for message generation and message underscore runtime, and repeat it for the build export depend and the exec depend tag as well. Now open CMakeList file and add the message generation dependencies in the Find Package section. Then scroll down and in Generate Messages uncomment this section, the whole one. Then we need to uncomment the Catkin depends belonging to the Catkin package in the Catkin configuration section. And we need to add message runtime. For the moment, that's all we need to do in the package and the Catkin section. So to check if everything works well, let's build the package by typing Catkin make in the Catkin workspace and see if there's any errors. Okay, it seems not. So now what we need to do is to actually create this message file, and we are going to do that in a new folder called messages. And by the way, it's very important to call it exactly MSG folder, and we will see it later on why. And then create a new file, and let's call it battery status.msg. It is a bad practice to put a capital case for the letter that compose your file when you create a message or services. Okay, we want this message type to be representative of a status of the battery and the situation of the robot at the moment. Why that? Because when we want to call a service, for example, we just need to know where the robot is in the environment and the percentage of the battery to see if we are too far away from the charger. So we need to create a pathway to come back to our home. Otherwise, the risk is to stuck in the environment because we run out of battery. Okay, this is the purpose of the project that we will compile later on. So as a recap, we need to create these new messages that is gonna be representative of the battery status. And what could be a good representation of the battery status? Well, for example, it could be the percentage of the batteries at the moment, and it simply is a primitive type of data, int 64. Let's put percentage underscore battery. And we can have as location in x, y, and orientation in theta a primitive type of data that could be float 64, and a bool variable to say us if the brushes are up or not, and a string type for a debug message, for example, if everything's go okay or if something went wrong. Okay, now save and go to CMakeList file and uncomment the add message file and put the name of our message, that is gonna be battery status.msg. And now you can see that it is important to put this file in a folder called exactly msg. Otherwise, CMake could not build properly the package and the header file that we are gonna see in a moment. And now build the package in the Kakin workspace. And see if there's any error, and it seems not. So ROS is building our message header automatically, and if you want to see, we just need to go in the devel folder of our Catkin workspace, include Roomba message, and you can see that the file is already created automatically from the build system. And as you can see, over 200 lines of code are generated automatically as an header file that can be very easily to include in our package if you want to use that type of message battery status. So it's a very useful tool in ROS. And what you're gonna do now is to use this type of message that we have already created in our Roomba pathway package that we have created in the last video. And before running into a simulation environment, let's create a new node just for testing if we can print our message type of data. And to do that, before diving into the creation of a new script of node, we need to update the CMakeList file and the package file in our Roomba pathway package in order to include the Roomba message package. And then we need to create the Roomba battery status file. And as you can see, we are updating our CMakeList file and packaging file, adding the Roomba message dependencies. Okay, let's start to create our node. And let's include the ROS header and the battery status header file that we have just said before. Create the int section and initialize the node, giving it a name, battery status. As you can see, this is nothing new from the previous video. Create the node handle object and create a publisher object as we did in all the videos so far. Nothing new again. But this time you have another type of publisher. So let's type n.advertise open brackets and give it the type of our message that is going to be of type Roomba messages battery status. This type of message will be published on the topic Roomba/battery status. So we put Roomba as some kind of namespace. And since that we want to publish a stream of data, we are going to create a rate object, so we are going to set the speed of the publishing stream. Inside the while loop, create an object of type battery status, and we are gonna call it message, and assign a value of each variable that composes the message itself. I have already done offline a Python script to test everything, but as you can see, the structure is the same as it is in C++. And finally, you can publish the message and let ROS spin the node once. So before test it, we need to add an executable instruction for the new node created, and we can call the executable file Roomba battery check. Save everything and build the package, and let's try it. First of all, I remember you that you need to turn on the ROS master and run our CPP code. Okay, it's up and running, and let's check the ROS topic list and echo on topic Roomba battery status for checking what is going on right now. So let's check the ROS topic list and echo on topic Roomba battery status for checking what is going on right now. And as you can see, the node works fine and the message is published correctly in the structure that we have created in the custom message. Awesome, that's all for today. If you liked this video, subscribe to the channel and turn on the bell for not losing the next topic where we are going to create a custom service. Thank you for your attention and keep learning robotics with ROS.